Neil is a developer for a very interesting, very active open source project that will facilitate our operational lives. Neil?
Afternoon, everybody. I've never actually done public speaking before, so I think over the next 30 minutes I'm either going to forget what LibreNMS actually is, or I'm probably going to forget my own name, but I'm going to give it a shot anyway. So, yeah, here to give you a bit of an introduction to LibreNMS. Some of you may have come across it before. You've possibly maybe used the fork where we originated from. So I'm going to run through and try and just give you an overview of the features and things like that. So yeah, originally it was forked from a piece of software called Observium. That was just over 4 years ago, or just around 4 years ago now, in October 2013. The Observium software at one stage changed its license from an open source license to quite a restrictive license. There's other reasons as well why the fork originated. You can Google some of the past history there. Again, people might have experienced it. But because of the change in license, we obviously had to go back to when the last GPL code was published, which unfortunately was May 2012. So we lost roughly about 18 months of code development from Observium at that time. So when the fork was originally done, it looked pretty shoddy, it had a lot of bugs in it, a lot of features missing that people probably expected to have when they were running Observium as well. So over the last 4 years, there's been a lot of work gone into try and bring the features up to parity, if you like, but also to extend it past that and kind of let LibreNMS run on its own as well. So internally, we don't pretty much talk about Observium. We don't really discuss it with anybody who comes along and asks us, what's going on in comparison to them. We're off on our own now. So the original fork was done by two chaps, Paul and Tyler. Tyler's off doing his own thing now, but Paul, he's still around, doesn't really get involved much in the code or the community. He much prefers being off now talking about NTP for some reason. He was doing a talk yesterday at NLNOG, I think on NTP. So what is LibreNMS? So it's an auto-discovering network monitoring system. Auto-discovering has actually got two parts to it, and I'll cover those off in a short while. It's written in PHP and MySQL. There's already been a comment made over PHP this morning. That's what it was originally written in when the fork happened. It's got us to where we are today, but it does hinder some of the development and also some of the performance that people expect from software like this. So internally we've been discussing about switching the polling and the discovery features from PHP to another language, to be determined yet. We've not really discussed it to that level of detail, but it's on the cards. We hope to switch it across to something else. JavaScript, no thanks. So pretty much all data collection is done over SNMP. I'd say probably about 95% of it. We do actually make use of CheckMK's agent. We can pull a lot of data in from that as well, and we have people who've contributed some additional code to the CheckMK side of things, but 95% of it's all SNMP based. Aside from storing the data in MySQL, which is obviously where we store all like the inventory information about VLANs, IPs, MAC addresses, etc. We store all of the statistics used to generate graphs using RRD tool. That's the primary one that's available and turned on by default. We do actually have support for InfluxDB, Graphite, and OpenTSDB. We only support at the moment sending data to those storage mechanisms. We don't actually support rendering graphs from that data. We have started a version 2 of the web interface, which will hopefully then make use of those other data sources at a later stage and just give people a bit more functionality within the graphs, make them look a bit nicer, etc. Yeah, so network and inventory information. I mean, that's primarily when you go and add a device into the system. That is what we're there to try and gather from all of your network devices, your servers, etc., and display that in an easy-to-use web interface, along with then obviously graphing historical data from ports, memory, CPU, health information of devices, etc. All the graphing's done via RRD tool at the moment. As I mentioned, we're looking to swap that out at some stage, but at the moment that's what we're making use of. And as links would say, we provide graphs that go up and to the right for exchanges, hopefully. This is not the best graph to show that, because it kind of goes up and to the right and down and to the right. The way the graphs are generated for port information, we do in and out on a positive and negative axis, unlike things like cacti where everything was stacked together. Gives you a bit of an idea though. That's a single port graph that somebody kindly shared with us the other day putting this slide together. Up into the right graph that you don't want to see, this is actually from the storage graph of our MySQL server, which is running our LibreNMS install at work. Yes, we weren't running monitoring. Yes, we weren't monitoring the disk space on that. So over the course of a couple of months, as a slow query log continued to chew through disk space, it eventually wiped out the MySQL server for a 24-hour period. So that's not the kind of graphs that you want to see on your networks, hopefully. So a bit more of an overview of the project as well. As I mentioned, where we forked from, there's past history there, and again, you can kind of look around what's gone on there. The project was forked originally to try and create a community-involved, a really nice community-involved project where people can come along, they can ask the stupidest questions and not get belittled for it. They can just go along, ask for new features, new devices to be supported, etc. And whilst obviously we don't have a full team of developers going off adding these functionality in these new devices, they can sit in the list and people will go through and try and work on them as best they can. But we aim to be inclusive to everyone. It doesn't matter what your background is, it doesn't matter what you've done before, what software you've used before. If you want to come and get involved in an open source project and specifically something to do with network monitoring, then we're aiming to try and be that project that people can just jump in and help out with. The license, I know not everybody agrees with GPL v3, but because of the original license and what was chosen at the time of the fork, we're GPL v3 at the moment. I think it'd be quite hard to change that and apply a different license now. But it is fully open source. We don't hide anything behind closed doors. We actually publish as much information about what goes on in LibreNMS as we can do. Just some quick GitHub statistics. So I said we're not a huge project by any means. And it's been running for around 4 years now. So over that time, we've had just over 400 contributors, and that can range from anything from just simple documentation updates all the way through to adding some core functionality that we now have. So that's equal to about 14,000 commits and 4,000 pull requests. So, we do okay. It's a busy enough project with a few people working on it. Issues, we've kind of stopped using GitHub issues nowadays for doing general help and support, so the number of this is tailing off. It's mainly used now for genuine bug reports and people asking for device support, which we then can actively track and try and get it added in as quick as we can do. So run through some of the core features that the software provides. A lot of it is what you would expect from a network monitoring platform, but I'm going to kind of run through them anyway and just explain what we do with them. So I talked about the auto-discovery at the start, and there's actually two aspects of this. One of the auto-discovery elements to it is when you go and add a device, maybe your first device into LibreNMS, it will, without you having to tell it what type of device it is, what information you want to be collected, it will go off and discover off that device things like, does it contain CPU, memory, etc., how many ports are in there, VLAN information, IP addresses, and it'll just start to collate all that information straight away within around 5 minutes. So the first aspect there of auto-discovery is what does the device tell you about itself? What can you gather from SNMP on it? The other aspect of it is, again, you should just be able to go in and add a single device to start with, a router or a switch or something like that. If it runs any of these protocols like CDP, LLDP, etc., then we can use those neighbor relationships to be able to look up the next device in your network using credentials that SNMP credentials that you provide. We will then go off and rediscover the next device in the chain and continue to do that and spider the entire network over a period of time. If you don't want to configure that side of things, or you don't want to wait for maybe 24 hours for all that to run, you can actually just go off and do a complete SNMP scan across different IP ranges. And again, the software will just detect SNMPs running on a device, and then it will try and auto add that device in using SNMP config you've already provided. We'll even try and add devices that you can you'll see neighbours for on things like OSPF, ARP, BGP, etc. So you can obviously restrict what happens there, because going to an IX, you don't want to all of a sudden start trying to add in all the neighbour devices on an IX. So you can configure your IP ranges where you expect these devices to sit, and then the software will go off and just look for those neighbours and try and automatically add them in. I'm not too sure how well this is coming out. Not very good. So one thing that came across with the fork was just pre-built dashboards. You got what was in the code base to display what information was there, a map, interface statistics and things like that. So one of the things we've done is we've tried to scrap all of that, and we try and make everything as dynamic as possible. So we've built a dashboard system. You can then go in and add widgets to that dashboard. You can create shared dashboards to share them with other users, create it for NOC wall screens, etc., which is where this dashboard has come from. One of our users kindly sent it across a couple of days ago. You've got simple information up there, like your map of where all your devices might be. It's not so great if everything's in one data center, but if you've got devices around the world or around a city, then it can show you all of those. You've got alert information and log information across the bottom there as well, network statistics off interfaces for top devices on the network at the time. There's a variety of different widgets there, and we do try and add more as and when people sort of give us ideas what they want to see next. So yeah, alerting. I mean, obviously, wouldn't be a network monitoring system without actually being able to tell you what's going on when it's found something happening. The alerting that came with the product originally when we forked was pretty basic. It was all statically defined kind of rules that would trigger off port usage and a variety of different things. So one of the original maintainers of the project rebuilt the entire alerting system. I would say it's complicated to get started with. You look at it and just think, what the hell is going on with this? Once you get to know it a little bit better, it's complicated because it's actually quite flexible. So you're not stuck with having to use either predefined alert rules or just a bit of a web interface to create them yourself. You can actually just go off and basically what happens with the alert rules is we convert those into MySQL queries. So you can go off in the background and write those MySQL queries, if you like, to just extend out the alerting functionality that we've got in there. So a very basic, simple rule, hopefully clear enough. That one will pure and simply just tell you if a BGP neighbor goes down. It checks that the device that's running that BGP session is up still, because obviously if the device is down, you're going to want to know about that rather than a BGP session. But that's come from the web interface. There's a lot more options that come along with that, of setting things like interval times, delays on when the first alert goes out, etc., maximum number of alerts. But the actual rule set, that's how it looks in the web interface. So that's a simple rule. You can get a bit more complicated and still do this in the web interface. This is obviously a completely made-up example there, but it does show you a bit of the flexibility that the alert rule generator can do. You can do specific matches, wildcard, negative matches, etc. So we're looking for a device here that's not in Buckingham Palace in the UK. Whether we'll find one or not, who knows? And off the back of this, if the web interface doesn't do what you want, you can turn to macros. So that is where you can just define in PHP, you can define a more specific rule that you might want to run. And again, it just translates to a MySQL query. So anything you can do in MySQL, you should be able to do in one of the macros as well. So hopefully you won't ever get stuck trying to alert on something that's just not possible to do. Obviously, how do we then get these alerts out to people? We utilise something called transports. These, again, are user contributed a lot of the time, and we're running just over 20 available transports. It includes your typical ones, sending notifications out via email, IRC and Slack nowadays, but we do have some real obscure ones that people have come along and added, so sending your alerts into Syslog or Elasticsearch directly, Obviously, people want to use existing tools, maybe to manipulate that data and do something else with it. But there's a lot more. We support OS ticket, push bullet, things like that. And it's quite trivial to add additional support in. If a service has got an API, we can add support in quite easily. This is a wall of text, really. So we've got a template system in there. We include default templates, so as soon as an email alert's generated, you'll get an email which tells you what's gone on with that alert. But you can customize that. So you can change a lot of the variables, you can change the formatting, you can convert it to HTML, etc. But it's entirely up to you how you want those alerts to appear. You can change that there. We probably should have used a templating engine, but the chap who originally wrote this kind of made his own up at the time. We will swap out at some stage for actual templating engine to make it a little bit easier, but this is our own take on it at the moment. Okay, for authentication, so by default, if you go and add a user into LibreNMS for one of your NOC engineers to log into, we just store it in MySQL. We do typical username and password within that. You can set the level of the access that person has, full admin access, read-only, or you can give it just so that they can access specific devices, or even down to specific ports. So you can kind of restrict what users see within the system. If you obviously have single sign-on system already set up, then you can make use of some of the authentication plugins that we've got, Active Directory, LDAP, Radius, and we also support two-factor authentication as well. So if you've got some users who want to do 2FA against their account, you can turn it on per user account. Okay, yeah, some of these aren't coming out very good. Could have chose different colours. So we have Syslog inbuilt into the software. So if you've got a relatively small, moderate-sized network, then this will probably function okay. I think if you've got an extremely large network, pumping Syslog across to LibreNMS isn't going to scale, because again, we do store everything in MySQL, so you're going to hit performance limitations, etc. there. But for, like I said, small, medium networks, it works quite well. You can ship all of the Syslog information to it. We have inbuilt hooks, so tying into things like Oxidized, you can then go off and force an Oxidized config backup of a device when a certain Syslog message comes in. If you want to go past that and do something a bit better, then something like Graylog is a lot better suited. And we do integrate directly with Graylog, so we make use of the API that they have there. You should see pretty much the same kind of information that we do with the internal Syslog as you do with Graylog. So host names, date timestamps, the message, the severity of that as well. And we display all that in the web interface for you to search through. Again, Oxidized, that was mentioned earlier. I think all the core contributors to LibreNMS are massive fans of Oxidized. We inherited the Rancid support, and there's been very little work done on it, and I'll be honest and say there's probably going to be no more unless somebody else comes along and contributes it. All of our focus when we've been adding any functionality to sort of integrate with a config archive system has been through Oxidized, and we're going to continue to do that as well. So there's actually two parts of the Oxidized setup that we've got. You can use LibreNMS as a source for Oxidized, so utilizing the API that we have, you can connect up your Oxidized installation to LibreNMS, and it will just automatically pull in all those devices, and then obviously, as long as your config's right, it'll go off and start to back up those devices. For the opposite way, we take as much information out of Oxidized as we can do. In essence, you probably don't need to go back to the Oxidized web interface after this. You could do everything through Libre. So you've got a bit of a screenshot there to show the nodes that you've got in your list, the status, the last time it was backed up. You've got the ability to go through and search through the configs as well. Again, mimicking basically what Oxidized web interface does. The first part that got added was obviously displaying the configs directly into the devices. So if you're browsing through your devices in LibreNMS, you can go to the config tab, and we pull in all of the information that Oxidized provides there. If you don't use Git backend for Oxidized, I'd recommend you do that anyway. But with it, you then get sort of versioning, and you can do diffs against the configs. And again, we display all that within this web interface here, so you can jump from device to device, look at the configs that are available, etc. So yeah, I mentioned the API already. We've had this in for a couple of years now. We initially made it so that other users can integrate existing tooling in your NOCs, in the support environments, etc., to obtain information from LibreNMS. You can export a lot of information, sort of BGP sessions, ARP information, IP address information, the actual devices themselves, and also graphs as well. So again, if you want to create custom wall screens and things like that, you can hook in using the API and pull out pretty much any of the graphs that we display in the web interface directly into your own systems as well. We did have a company, I'm going to move on to that in a bit, they're making extensive use now of the API to build 2 mobile apps that go alongside LibreNMS. I'll touch on those in a short while. Another not so good image to see up there. You don't really need to kind of see what's going on with this, but as I mentioned, the software is written in PHP, it's MySQL backed. That has limitations. You know, as you're building a bigger network, you've got more and more devices being polled, more and more information being stored, you're going to start hitting bottlenecks. The company I work for at the minute, we run about 4,500 servers through this. So it got to a stage where we kind of needed to do something else to be able to continue to use LibreNMS. So the simple ones you start off with, sticking web server, database server on its own. You can move all your RRD onto a dedicated RRD cached box to speed things up, but you'll get to limitations then in the polling side of things, which is the service that goes off and obtains all of the data and all of the information about your devices. You're going to hit bottlenecks at that point, you're going to hit limitations. So again, one of the users kindly contributed some code to be able to split out into multiple pollers, so you can run 1 to X number of pollers, and these will then go off and just cycle through all of your devices, doing all the data collection as normal, trying to keep it within a 5-minute window. I mean, the cron runs every 5 minutes, and so that's the aim of the game, is to do all this within 5 minutes. So we've extended out Job's Polar Wrapper script that he kindly open sourced many years ago. That's the distributed polling aware, so we still make use of that, but then it hooks into things like memcached just to keep a list of what devices need polling, etc. It does have the flexibility then, so if you've got a site which might be an office-based site which is running NATs, obviously rather than trying to punch holes in or do SNMP port forwarding and things like that, you can actually just drop a polling box within that office environment. It can collect all the data from the local network and then ship that back out to the centralized instance. So you end up with one pane of glass. You can see everything through the LibreNMS one web interface, trying to make it as easy as possible. I think the next stage of this will be changing the pollers away from running PHP. There's only so much performance we can get out of these things. This is something that was included as part of the fork. We have done a few bug fixes and little tweaks as we've gone along with it, but it's a traffic billing system basically. Doesn't go off and generate invoices for you, doesn't do debt collection or anything like that. But what it is there to do is it's an inventory again of your customers, you know, how much connectivity you've sold to them, etc. So you can do it on CDR or quota based, you know, 10 megasecond or 500 gig over a course of a month. And this system will continuously poll for all of that data using SNMP again, polling directly to the ports that customer might have. We store the information in MySQL, so it gives you the ability then to drill down into a per day and per hour view of what traffic has actually been generated there. So rather than with the graphs that we generate, which obviously again get consolidated down as time goes on, using the traffic billing, you can keep quite a granular view of a single port or multiple ports within a bill over a period of time, and that data is kept indefinitely. You can age it off at some stage, but it's kept as long as you want. So you can obviously set some information in there just to track things like billing day, customer reference information, etc. So again, we expose that via the API. You can tie that into your internal systems, so you could then go off and generate bills automatically, etc. So that's just a quick graph there. It's showing a month by month usage, but you can drill down within that, and it just kind of shows you the information that's stored and collected. So we've got an automatic update system. We run 2 different channels for updates. One of them is a stable release that we do once a month. And the idea with that is we get to the last Sunday of a month. We aim to only include commits that are a few days old or a few days before the release is done, so that we can try and maintain a stable release. Because obviously, if you go along and update your NMS and all of a sudden you start losing graphs and historical information, it can be a bit of a pain. So the stable release that we provide, I'd like to think has stayed pretty stable. We actually did a blog post on this a couple of days ago because we released version 1.31, which ended up as 1.31.03, just because we had a couple of bugs introduced that we needed to get fixed and re-release, etc. But that's only the second time that's happened. I think across something like 30 releases we've done, there's only been 2 times where we've had to do a bug fix and re-ship out a release. The default when you go to install, though, is the master branch. We use that as our development branch, basically. So everybody who doesn't switch across to stable monthly releases is doing us an absolute huge favour, because you basically beta testers for us. We obviously go through automatic code reviews. We do manual code reviews. Where needed, we'll test them manually on development environments that we've got. But sometimes we're not able to test everything, every single device that's out there, every setup that people have. So if you run the master branch, thank you. You are bug testers for everybody else. So I mentioned earlier, using the API, the company's gone out and actually built an iPhone and Android app off the back of the API work that we've done. So they were originally big users of Cacti, and then they've slowly been transitioning across to using LibreNMS. But the one stumbling block they had was somebody has written a mobile app for Cacti, so you can on the go just get a view of what's going on in your network. None of the core maintainers for our software have got any experience in developing mobile apps all the time, so we were never going to sort of introduce anything like this. Luckily, a company called Wave Direct over in the States allowed one of their engineers to go off in their time to build these 2 mobile apps. So they're freely available for anybody to use. They are saying that they're going to release these as open source, so we're hoping to push them to get that done, and then obviously people can start contributing, hopefully, to the mobile app side of things. We do use Bootstrap on the web interface, so it's mobile friendly-ish, but the type of information we display doesn't lend itself typically to mobile devices. So these have been a godsend, absolutely brilliant to use. So yeah, I've run through the 2 release branches that we've got there, but the installation process is pretty straightforward. I think a lot of people still go off and do a manual install of the software from, I'd say, start to finish. Shouldn't take any more than 15 minutes. At the end of the day, it is just a PHP application. There's nothing super complicated about it. We've got installation instructions for CentOS and Ubuntu, choosing whether you want to run Nginx or Apache. But it's pretty much just a copy and paste job. If you're doing it on a from scratch server, you can pretty much just copy and paste all the commands in there and get something up and running within about 15 minutes. If that's not for you, we do have virtual images available as well for you to download, so you can just import into your virtualized environment. They are built with VirtualBox. I don't run VMware, so I've not been able to build VMware images. You can convert them and run them in ESXi, and we know people who've done that before. And then, thankfully, other people have started to contribute things back, like Docker containers as well, just to try and ease the deployment process for some people. So if you look on GitHub and just search around, you will find Docker support nowadays, developed by somebody else, but we're obviously very grateful of all the help we can get with that. And again, some users who've deployed LibreNMS in their work, tying it into their automation tools using Ansible and things like that, they're now contributing those scripts back. So again, if you use these tools, you can go off and just run these playbooks instead of building or deploying virtual machines yourself. Just utilize what's there already, basically. And again, all available on GitHub if you just have a search around. So device support. So we don't go out to support specific devices. We actually do sort of OS support within there. So things like iOS, Junos, etc. We'll add the support for that operating system itself. which then obviously powers a lot of the devices that you might want to add. We've got detection now for just over 350 different OSs within that. Keep switching between using vendors and devices, etc. But it's basically OSs, and we're continuously adding those. That's the most requested feature all the time is new device support for something. We add roughly 30 new devices every single month. If it's not a full new device support, then it might be additional information. We might have added detection for a device 3 months ago and somebody else comes along and goes, hey, I want to see more health information for this device. We go through and try and add as much as we can each time. Yeah, it's PHP based, so I know it doesn't have its fans PHP. It has worked for us, but historically, going through and adding new support for devices and health information, it's been PHP. You've had to go off and either know it already, work out what the code's doing, or just copy and paste from another device that's quite similar, make your changes, and then hopefully submit them upstream. What we've been working to do, though, is to abstract the device support, if you like, away from the code base, with the view that we might swap PHP out at some stage. We obviously don't want to have to rewrite all of the device detection and information collection that goes on in PHP. So we've started to move across to YAML. Again, there's some similar words being used all the time. So nowadays, if you want to add a new device support or health information, those are the two areas we've converted, then you can define this information in a YAML file, and then the code does what it does and adds that device in when you populate it. A couple of days ago, we did merge some really poorly written code, but we've just started now trying to allow users to be able to generate the detection themselves. So rather than always having to come back to the developers to do it, we've just put a quick script together. You can type in a bit of information, provide it a MIB file, etc., and then off you go. Okay, I'm sure there's quite a few people who've worked on open source projects. We do get users who rock up to us asking for help and support, thinking this is how it is. It genuinely isn't, and if anybody's seen this cartoon slide before, that is how it is for the open source project. I won't lie, you know, I've been stood in the shower before with my mobile phone, replying to IRC messages and things like that. You just do it any minute you can. It's just one of those things. But if you know, I love working on this project, so I don't mind putting the time in. You kind of just run around headless from one thing to the next, though. If you need help, so IRC is our primary method of communication. We have looked at moving across to things like Slack, etc., but IRC keeps winning hands down for everybody who's there. We've got about 200 users hanging around the channel. It's actually quite quiet nowadays. I'm hoping that's because it's more bug-free than it ever used to be, rather than people don't want to talk to one another. But it's definitely a lot less crazy in there. We introduced a community site about 18 months ago, so that's based on a discourse forum. It just means we've got a bit of a searchable history on people asking the same questions again, etc. And that's been a godsend. Again, it seems to be driving that community feel and getting more and more people involved. Reddit. We fell into supporting people on Reddit. One user asked for something, then the next user asked for something, then somebody created a Reddit channel for us. Now we help out quite a bit in there, and we seem to get quite a lot of love in Reddit. We get upvotes all the time, mentions all the time, etc. So it's been useful for us. Github, it used to be for anything. Now we use it just for new device support and bug requests. Or bug finds. So if you've got any issues like that, please do drop them across to GitHub. We're always looking for people to get involved. I know I'm running out of time. I'll try and rattle through this quickly. We've gone through 400 contributors. There's typically only a handful of people who stick around and help out on a month-by-month basis. But if you use the software and you want to contribute anything back, it doesn't have to be code. You can hate PHP as much as you like. Contribute some documentation. We always need improvements. You know, engineers and software developers are not typically very good at writing documentation, and we're the same. Stick around and help others. You know, we've got some people hanging around in the IRC channels and the community site now. They step in to answer questions all the time that people might come across. And please, if you find bugs, report them in. We genuinely do want to get things fixed when there's issues. If you've got a device that comes up as generic, it needs device support add-in, so come across, provide us the information we need, and we can go off and add support for it. There's some contact details if anybody wants to get in touch. Variety of different ways. We hang around in a lot of social channels. And we're pretty responsive in most of those as well, apart from Facebook. I'm not a big fan of Facebook, so I don't answer messages there. Everywhere else, we're pretty active. That's it. Has anybody got any questions?
Well done.
4 minutes. Sorry.
What's not to laugh about Facebook? Because that's written in PHP as well. Yeah, any questions for Neil? All right.
That's a good thing.
Yeah, that aligns with our time schedule. Give it up for Neil. Thank you for your presentation.